In this video, we're going to be looking at bar graphs, including the Pareto charts, circle graphs, and time plots. Looking at the bar graph first, our first example is going to be number of each color in the bag of M&Ms. Here's our data. We have the 4 different colors and how many of each color were in that bag. You can see over here we have our X and Y axis, horizontal vertical axis really, where we have our different colors along the bottom. Now bar graphs work. You'll notice that this is nominal data. Right? These are just names. Right? There's no order particular to them. And the vertical axis is the frequency. It's how many are in each one. So all we need to do is make each bar the right height. In general, the bars are not not connected to each other. There's a little space between them, which is an indication that one does not necessarily flow into the other, like a histogram. We'll talk about histograms in a little bit. So here is what the bar chart will look like. So this is the bar graph showing the different heights, different amounts for each color. The next thing we're going to look at is the Pareto chart, which is very closely related to the bar chart. So what I'm going to do is I'm going to erase this bar chart and start over again. Now you'll notice that not only did I get rid of the bars, but I got rid of the names along my horizontal axis. Because the Pareto chart is in a particular order. It goes from greatest to least. So what I'll do is I'll put the names in that order. So here they are in the order, and now I can put the bar graph together. And here you can see I've arranged it so that it's in descending order, which is what you need to do in a Pareto chart. Now the actual height here, I've just done approximate to the scale I've drawn. If I wanted to be more precise, I could actually measure and see what they would have to be, but this gives you a pretty good idea of what that would look like. The next chart we're going to be doing is the circle graph. We're going to be using the same example, the M&Ms and the different colors, only now we're going to do a circle graph, also known as a pie chart. And we'll figure out what the different regions have to be. Now to start with, we're going to have a circle, and we're going to be dividing this up into pie pieces. To know how big the pie pieces are, what we need to know is what percentage each color is. So to figure out the percentage, we need to know the total. So we add up all these, and it turns out there were 442 M&Ms in this particular bag. And what we need to do is divide each number by 442, and then we're going to get the percentage. So here's the results of all the percentage work. Now these of course are the relative frequencies. 0.20 would of course be 20%, 34%, 31%, and 15%. Now there's 2 ways to go about drawing this circle graph. One is what I like to call an approximate circle graph, in which just kind of look at this and we're just kind of ballparking the different sections. Here's the center of the circle. I like to start with a nice vertical line. I look at these two and say, well, a third is 33%. And both of these are pretty close to a third. And I know pretty much what a third looks like. That's approximately a third, though not very precise. And so I could say maybe this is the 31%. And I'll do on this side a similar division. And that's maybe my 34%. So that's yellow, and this would be brown. And then this last piece, well, that's 20 and that's 15. Looks like blue is a little bit bigger than green, so I'll just make them a little unequal. And so this would be blue and green, and we have, a decent approximate pie chart or circle graph. Now, if we want to be more precise about it, then we kind of need to start from the beginning. And now what we can do is take these percentages and say, well, those percentages will tell us out of 360 degrees what each part of the circle should be. So what we'll do is we'll go 0.20 times 360, and that tells us that that first part is going to be 71 degrees in the circle, right? And then we're going to do the same thing with the rest, looking something like this. So now we have the number of degrees that we could draw each sector of the circle with. Now at this stage, I'm going to want a little bit more space, so what I'm going to do is I'm going to copy these numbers down onto the next page, just like this. And I've set my center of my circle right here, and what I'm also going to need is a protractor. So here I have my protractor, and what I can do is set the center of the protractor at center here, and I know that my first number of degrees is 71, so I'll start here, and 20, 30, 40, 50, 60, 71 degrees right there. My next, now I can move this around. I can do this in different colors. That was blue. Now I can do yellow. Is it going to be in 124? So that's, oops, that doesn't seem to be drawing very well. I'll use different color. Alright, I seem to have worked out whatever issues there are. So 0 is going to go up to 124. I'm going to start over here. And there we are. And there's my 124 degrees for yellow. Brown is going to be 112. So I can fix that. I can select brown is 112. Hopefully this is going to work, and it does. So we got that. And then of course the balance will be green. Oops, I have to back that off a little bit. There we are. So now I can get rid of my protractor. I have my circle, and now all I have to do is try and connect it up. Easier to go from here to there, I suppose. Using a ruler might be a little bit easier. There we go. And we have a much more precise drawing. This is it is 71 degrees, but we should put our percentages. Right, this is 20 degrees. This is our 34 degrees, percent, sorry. This is the 31%, and this is the 15% for the different colors. Last example is going to be the time plot. So I'll put the example, we're going to use rainfall, average rainfall per month. And here I looked up the average rainfall in millimeters per month in Missouri. So this is where we are. Now what we need is a time plot. Of course, this is data which changes over time. So we'll have our axes. Here are the axes. I, of course, have set the bottom to months and millimeters of rain as the vertical. And now each data point is going to be a single point. It's a little different than the bar chart. So this is what it's going to look like. So here I've plotted all the points, and then on the time plot what you end up doing is connecting them like this, and you get a nice display of how things have changed over time.